Now these two functions, let us compare which one is greater. So for this, I will apply log on both sides. So this is log of n power log n, and this is log of 2 power root n. Now this power comes out by applying third formula. So this becomes log n into log n. So that power came this side, so that is log n, and all that it is log n. And this power comes this side, so root n log 2 base 2. This is 1. Now what is this? Log square n, and this is root n. Now which one is greater? If you are unable to judge it, still you can apply log. Directly I will write the answer. If I apply log, then this will become 2 log of log n. And this becomes, this is n power 1 by 2, right? So 1 by 2 log n. Now tell me, which one is smaller? Log of log n is smaller than log n. Yes, this is smaller than that one. With applying log for one time, if you are unable to judge it, then you can apply log again and you can judge it. So here the thing is, we have to judge which one is smaller, which one is greater. So for making it easy, we are applying log. There is no rule, there is no formula, right? Just apply logs so that you can reduce it and see, and you can easily compare them. So here we one time applying, we were unable to do it, so we did it again. Again confusion is there, log square n may be greater than just root n because this is square. So just apply log one more time. So you got log of log n, and that is just 1 log n. So log n is greater than log of log n. Now let us see who is greater. Two functions. Apply log. Log n into log of 2 base 2. This is 1. And this is root n log n. So what is the answer here? Just log n, and this is root n log n. This is greater, so this is smaller. F of n is 2n, g of n is 3n. Which is smaller, which is greater? Both are equal. Both are equal. This 2 is ignorable, 3 is ignorable when you take it asymptotically. Big O of n, or theta of n, or theta of n, both are same, both are equal. Both these functions are equal. Now, which function is greater? This looks smaller, this looks greater. Let us apply log. Log 2 power n, log 2 power 2n. So this n comes this side, log 2 base 2, this is 1. And 2n comes this side, log 2 base 2, this is 1. Now which is greater? Now don't say they are equal. Don't say they are equal. We have applied log. Then we are comparing them. Now I cannot say ignore that too. Directly in the functions you can do that. Now for comparison purpose we already apply log. So you cannot strike away the coefficient. So this is 2n, that is greater, and this is smaller. So yes, this function is smaller, that function is greater. You can clearly see from here only. Now I have taken this example to make you understand, after applying log, don't cut off coefficients. Don't cut off them. Right? In one of the example I did that, but that time I did not apply log. Now after applying log, I have changed the functions. Now if I cut off coefficient, it will be different answer. It will be a wrong answer. Directly from the functions you can cut off coefficients. So applying log, this 2n is greater than n, so that is greater. Actually this is 4 power n, this is 4 power n, and this is greater than this one. This example, let us compare two functions g1 and g2, which one is greater. Now here, it is not a single expression, here is n cube or n square. So for n value less than 100, it is n cube. After that, it is n square, so this is reducing. And this is n square up to 10,000. After that, this is n cube. If I take n values, let us say this is 100, and this is n, and this is 10,000. Now, on this side, who is greater? this side less than 100, G1 is greater. And from 100 to 10,000, who is greater? Because the figures are there, so I have used this on the bar. Now, from 100 to 10,000, who is greater? See, from 100 onwards, this is just n square. This is n square. And below 10,000 also, this is also n square. So this is also n square. So both are n square. So G1 is equal to G2. Here, G1 was greater than G2. But beyond 10,000, so 10,000 is n square only. After 10,000, this is n cube. So G2 is greater than G1. So this is still where? This is infinity. Now, who is greater? Which function is greater? G1 or G2? G2 is greater. Always. From what value of n? From 10,000 onwards, it's always greater. Before 10,000, they were changing their sides. Sometimes this was greater or they were equal. But from that point onwards, 10,000 onwards, always G2 is greater. So G2 is greater than G1. G2 is greater than G1. So remember this. So whenever you say some function is greater than another function, you don't have to take the small values of n. It can be from very large values of n also. But from that point, if it is always greater, then we consider that function as greater. Alright? We don't just check into smaller values and decide. For all values of n, we decide. Means up to infinity. So from 10,000 to infinity, there is no limit. There is no limit. So G2 is always greater than G1. Here some asymptotic notations are given and comparisons there. So we have to find out whether these statements are true or false. Let us check. This is n plus k whole power m, and if you open this binomial, right, two terms are there. So if you open this, it will be n power m. That is going to be a highest term. It is just like, for example, n plus 3 whole square. Then what is the highest term you get there? N square is the highest term. So if m is there as a power, so n power m is the highest term. So we can write this as theta of n square. Yes, it is exactly theta of n square. So this is theta of n power m. Yes, correct. This is correct. Then what about this one? 2 power n plus 1. So this is 2 into 2 power n. 2 into 2 power n. Coefficient is ignorable and it is theta of 2 power n also, big O also, omega also. Anything you can write. So this is also correct. Big O is correct. Then let us take this one. 2 raised to 2n and this is 2 raised to n. This is 4 power n and that is 2 power n. 4 power n is greater than 2 power n. 2 power n cannot be an upper bound for this one. Wrong. So it should be big O of 4 power n, not 2 power n. This is wrong. The next, this one. This is the root of log n. This is log of log n. Which one is greater? You apply log on both sides and check it. If you apply log, you get what? 1 by 2 log of log n. There, log of log n. Still more smaller. So that cannot be an upper bound. This is greater value. That is a smaller value. Smaller value cannot be an upper bound. Okay, this one, if I apply log on both sides, so this will be log n into log n. So that is log square n, and that is just n. So that n is greater. So yes, this is big O. This is big O. Right? So this is correct. So that's it. I have solved few problems using asymptotic notation so that you get the idea of what should be an approach for solving them. And you have some examples. These are the examples. Already I have taken the example. These are from some exams, competitive exams. So if you get any type of question now, you will be able to solve it. If you have practiced this little bit, then you can solve any type of questions on asymptotic notation. So here we end first chapter of algorithms. Like if you take any textbook, then or any university syllabus, the first chapter is about the algorithm, their analysis, and the asymptotic notation. So we have finished this. So in the next videos, you will find that is second chapter onwards. That is, we will look at the strategies, that is divide and conquer and greedy method. These strategies we will start.